Okay, good morning everyone, especially to you Ma'am Chang. So, today we're going to talk about the Earth crust. Okay, Earth crust. Our objective is all about the understand the origin, structure, composition, and evolution of the Earth crust. Also, the different type of the Earth crust, which are the oceanic and continental crust, and also appreciate into the real life. So Earth crust. Earth crust is the thinnest and the most elementary layer that make up Earth, and yet everything that has ever lived on Earth has called it home. The crust is dynamic structure, and it is one of the layer that makes up our pale blue dot. The crust is referred to as a chemical layer that has varying chemical compositions. Two main types of crust are the oceanic crust and continental crust. and they different from each other. The difference are due to plate tectonic, which refers to plate and the movement of the plate above the atmosphere, driving lithosphere process that result in the formation and production of natural phenomena such as earthquake and ridges. The crust is one of the 5 chemical layers of the Earth, and it's differentiated to show the distinct chemical properties occurring at each layer. The crust, along with the upper mantle, has its necessary role in the dynamic creation and destruction of the crustal surface, in which all living organisms thrive on. This chapter will look at various aspects of crust, and it will discuss the origin, structure, and composition of the crust before elucidating its continued evolution to this day. Okay, let's go to the origin of the Earth crust. The early terrestrial crust appeared approximately 4.5 billion years ago. After the late stage of planetary accretion, these sections describe the theories of the formations of the crust and discuss the origin of the oceanic and continental crust. Theories about formations of the crust. There are 3 main theories of formations of the crust: inhomogeneous and heterogeneous accretions of the Earth model, impact model, and terrestrial model. Inhomogeneous model, or the so-called accretion model, explain that the crust was formed during the accretions of the planet, with lighter and volatile element forming a thin layer on the primitive planet, which become the crust. This model suggests that non-volatile elements can only be found in mantle. However, this is not true. Non-volatile elements such as uranium and thorium are found on the Earth crust, making this theory highly unlikely. Okay. Second theory, the impact model, suggested that asteroid and other objects that impacted Earth melted and formed the crust. The oceanic crust, which is mainly composed of basalt, could have been formed by a basalt asteroid and impacted the Earth. However, form of observations of the moon basalt found in the lunar marea were not due to an asteroid collision. Furthermore, the number of basalt produced from the impact event was too insignificant to form crust. In addition, a majority of the impact event on Earth happens after oceanic crust were formed. Therefore, this theory is also unlike as well. Okay, let's go to the third theory, which is the terrestrial model. Terrestrial model is the most likely explanation on the formation of the Earth crust. This model explained that the crustal origin of the Earth was due to its internal process. After the late accretions of the Earth, retained by the Earth result in the complete melting of the upper mantle, which formed a magma ocean that covered the surface of the Earth. As the Earth cooled, the magma ocean crystallized to form a widespread crust. Another possible explanation was that the melted upper mantle rose up their surface to form a crust. The traditional model is most likely explanation, as the magma ocean could explain some properties of the earth crust. The uniform and compositions of the crust could be formed by a homogeneous magma ocean. The layered compositions of earth crust may be due to the cooling of magma ocean over time. Thus, the traditional model most likely explain the formations of the earth crust. Okay, let's go to the structure of earth crust. The earth has a thin silicate crust which make up 1% of the earth volume. It is the uppermost top component of the lithosphere and float on the top of upper mantle. The crust plus upper mantle is separated by the morphosic discontinuity, a seismic and compositional boundary. The crust is varied in the thickness controlled by the law of isostasy according to Erie model. The crust responds to topographical change, load or unload, by changing its thickness compositions, thus tending toward isostatic equilibrium. The crust is thickest under mountain range and thinnest under the mid-ocean ridges. The evolutions of the earth crust refers to the gradual development of crust over time. Geomorphically significant evolutions of earth crust fall into the main categories: endogenic process and force of the earth originate within the earth, and exogenic process that is a result of force from above on the planet's surface. Okay, let's summary and conclusions. While the earth crust may be comprised of the superficial layer of the earth, it is truly dynamical, fascinating things to learn about. Superficially appear to be a solid, immutable, covering the rock on the world. It is actually a collection of gargantuan rock plains in heterogeneous compositions floating upon equal colossal ocean of magma that has outer mantle. From its early origins as hot, lifeless shell covering our planet, to its current state and home for all life on Earth, it has changed so much over geologic time span of Earth history and continues to evolve to this day. Fortunate that the Earth would coincidentally have the perfect chemical composition to form crust suitable for forms to exist, all accordance with the physical law and govern the formations of world. The crust is truly amazing and astonishing things to learn and behold. So that's all about the earth crust, and thank you for watching and listening.